You can start now.
Hello everyone. We are the students of Environmental Science and Technology. Our project ID is 95927. Topic of today's presentation is degradation of wastewater by electrochemical advanced oxidation process. Our project is guided by Ms. Amishi Popat, Assistant Professor DEST. Introduction. Optimized treatment of industrial wastewater is considered a core subject of researchers across the globe, as it poses a severe risk to air, soil, and aquatic life, specifically to animals and human health. The industrial wastewater having high BOD, COD, castrant compounds, colors, etc. are discharged from various industrial sectors wherein the conventional treatment fails to remove all the pollutants from the effluent due to less efficiency, high operation cost, and feasibility of treatment. It is estimated that around 700 different contaminants are disposed into environment and are not completely metabolized and enter into sewage system, making their way to wastewater treatment plants. AOPs are proven to be cleaner technology that effectively degrade persistent toxic organic contaminants through various oxidation reactions with the help of very powerful hydroxyl radical. There are various AOPs, among which electrofenton has gained much attention nowadays. Short reaction time, formation of hydroxyl radicals through in situ electroregeneration of H2O2 and Fe2+, no transportation cost of H2O2, inexpensive Fenton reagents, etc. are some of the reasons behind choosing electrofenton process in the present study.
After selecting our topic, below are the few literature paper that we refer. First literature paper on the advanced oxidation process in the wastewater treatment. Hydroxy radical based advanced oxidation process have been studied for the treatment of the wastewater. Major purpose of the AOP is to remove the recalcitrant organic matter. We have referred literature paper on the textile wastewater treatment by electrofontaine process in batch modes. This mainly focus on the removal of a color and COD from the textile wastewater by the electrofontaine process. Experiments were conducted in the batch modes where find the optimum condition at pH at 3, voltage at 5 and ferric ion concentrated at 5 mg per liter. Where at this optimum condition, they have obtained 57% COD removal. Our objective of the project is to degrade the various recalcitrant pollutants from the wastewater by electrofontaine process.
So, in the methodology, the proposed solution to above mentioned issues is to find the optimum operating parameters at which we get maximum pollutants removal efficiency. For that, initially we measured few physiochemical characteristics of water such as pH, COD, BOD, color, etc. In process, 750 ml of textile wastewater was considered for all the electrolytic experiments, which was conducted in 1 liter capacity cylindrical glass cell. As anode, galvanized iron was used and stainless steel was used as a cathode. The depth of immersion of all the electrodes was kept constant at 8 cm and the clear spacing between the electrodes were kept constant at 2 cm. Before the electrolysis, the pH of textile wastewater was adjusted to 3 using 2 normal of sulfuric acid and then the oxygen was added to wastewater through aerators. The required amount of ferric chloride was added to the solution and a constant DC power supply was ensured at 0 to 10 volt. Samples were then withdrawn at regular intervals of 15 minutes by keeping one parameter fixed and altering all the others, and then the final characterization was done.
Result and conclusion. From the experiment, we studied the various parameters that play an important role, and they are: the first one is oxygen spreading rate. Oxygen is one of the major factors that limit the performance of electrofenton system because increasing the oxygen spreading rate can increase the dissolved oxygen concentration and the mass transfer rate of dissolved oxygen, and finally increasing the production of hydrogen peroxide. The second one is applied current density. The applied current is driving force for the reduction of oxygen, leading to the generation of hydrogen peroxide at the cathode. Higher applied current increases the quantum of hydrogen peroxide produced, thus increasing the number of hydroxyl radicals in the electrolyte medium, which are highly reactive and responsible for the degradation. The third one is catalyst concentration. Suitable ferrous ion concentration is an important prerequisite in the electrophantom process. Generally, the efficiency of electron phantom process increases with Fe2 plus concentration because the concentration of hydroxy radical, which is the main oxidizing agent in the electrophantom process, increase with the increase in the Fe2 plus concentration. So from the experiment, it can be concluded that the treatment of textile wastewater was carried out by the electrophantom process and factors affecting were studied. 31.65% COD removal efficiency was achieved with the help of electrophantom process as the initial value of COD was 2856 mg per liter, which got reduced to 1952 mg per liter at optimum condition. Thank you.